Bienvenidos, Ushamdi, and welcome CTS230, Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3 or the Scaling Networks V6 Cisco Networking Academy course, and this packet tracer tutorial and solution set is going to be on packet tracer activity 4.3.4.4, where we get an opportunity now to troubleshoot Cisco's proprietary hot standby routing protocol. So let's go ahead and dive in here to the packet tracer activity. You can see that we've got our setup here, and so here are our two what are commonly referred to as front door routers, right? These are going to give us connectivity out here to this internet cluster and then take us out to the Cisco PKA web server. We've got our addressing table, and let's take a look here. It says currently users can access Cisco www.cisco.pka. The network's been updated to use HSRP, and we've got to verify that all users can still access the website if one of the routers is down. R1 should always be the active router if it's functioning. So what that means is that R1 is going to have a higher HSRP priority setting. So let's go ahead and dive in here. Network requirements. HSRP virtual router is 192.168.1.254. So let's pull router 1 up, and we're going to have much more success here with our font. Much better, right? So we're working with routers finally here, right? This is a good thing. Now the font is nice and large, and you can see that on Gigabit Ethernet 01 for HSRP standby group 11 that we have transitioned from standby to active. Now, how would we check this? Well, let's go from user exec to privilege exec with the enable command, and let me say show standby, and if I do it by itself, that's going to give me quite a bit of information here, and let's take a look at some of this important information. We can see that what version of HSRP are we running here? What do you think? And there's a couple things that I'm looking at right now. Obviously, the giveaway is version 2. I was crossing version out there. So we can see that we're running version 2. We can also tell from the virtual MAC address, right? Remember that the HSRP v1 virtual MAC addresses are typically 00, I shouldn't say typically, but they're 0000 dot. And then we have this 0 Charlie 07 dot, and then we'll have a hexadecimal representation after AC, and then I'll put XX, and the range goes from 00 all the way up to Fox. So we can go all the way up to 256, I believe, are the number of digits that would be in there for Fox. So again, it goes from 00 all the way to Fox, and that gives away HSRP v1. The HSRP v2 is easy to tell because we go from 0 Charlie 9 Fox, right? And then after the period, it goes from Fox 000 all the way to Fox. And the reason it's all F's here, F, is because this is one of the advantages with HSRP v2, in addition to some other advantages, but this is one significant advantage here is that we can have from 0 to 4095. So in other words, we can have up to 4,096 HSRP groups if we needed. Okay, so you can see that it says preemption is disabled, the active router is the local router, the standby router is unknown, the priority is 50 because it's configured to be 50. So we can clearly see we may be having some challenges here. So let's go ahead. There's another command. We could say show standby brief. And this is a great command. This is usually one of the commands I start off with because it gives me a nice condensed look here. What is the interface over which I'm participating in this HSRP group? It's gig01. What is my group number? What is the priority on that interface? What is my state? right? Am I standby? Am I active? And you can see here it's active, and then it tells you who's the active node, because if we ran this on the standby, we'd want it to tell us who the active node is, but you can see local, so me. We don't know who the standby is. So we clearly have an issue here, and then there's the virtual IP. And then the final thing we'll take a look at is, let's say, show run. Again, I would say show run int gig01 on a real Cisco router, but Packet Tracer doesn't like that. So we're going to make our way down here, and there we go, Gigabit Ethernet 01. And so we just kind of validate things here, right? IP address, IP NAT inside, right? Because we're doing NAT out to that internet connection. We've got our duplex and speed, standby version 2, right? HSRP v2, standby group number, and our priority, right? Standby IP and our priority. So if we come over here and we look, we see HSRP virtual router is 192.168.1.254. Okay, so we're good with that. The HSRP standby group is 1. Do you see the problem here? Yeah, our standby group is 11. So let's come over to router 2. And my guess is that router 2 is probably also configured with the wrong, and you can see right away, right? Take a look at the group number here. So we've got all kinds of shenanigans here. We've got group numbers that are incorrect, excuse me, group numbers that are incorrect. We've got priority values that might not be correct. So let's get into privilege exec, and we'll say show run right out of the gate. And yeah, take a look at this. We've got the standby IP. We've got no standby priority, which means we're going to be using the default, which is 100. We've got standby version 2. So this is just a disaster, what we're looking at here. So here's what we're going to do. Let's go back to our requirements. Let's get back onto router 1, and let's fix things here. So let's get into global config, and I'm going to get into interface Gigabit Ethernet 01, and we're going to say no standby 11 IP 192.168.1.254. We're going to say no standby IP, and actually that may have removed, let's see if that got that out of there for us, the priority. It did. All right, so now we're at standby version 2. I'm looking up here. I don't see anything that indicates what the version needs to be, so we're going to roll with it. We're going to roll with version 2. Now, I'm going to say standby 1, and you'll see here, I think it is, yeah, with version 2, 0 to 4095. So we'll say standby 1, and we're going to say the IP is 192.168.1.254. Right, and it goes, excuse me, it goes into the init state. Now we're also going to say standby 1, because that's our group. We want to put a priority in what, let me double check that. Did it say use the default? R2 should use the default. So if R2 is using the default priority, right, and you can see we're getting some duplicate address messages here because of what we've got set up over on router 2. In fact, let me do this. Let's pull router 2 up, and we're going to get into global config interface, Gigabit Ethernet 01, do show run. And let's say no standby 111 IP 192.168.1.254. There we go. So that should take care of those error messages for right now. I'm checking to see R1 should be the active router. Okay, so here's where this is typically where Cisco will try to be sneaky with you. So it tells you that R1 should always be the active router when it's functioning properly, and R2 uses the default HSRP priority. So what that tells us is R2's priority is going to be 100, meaning we need to be at a priority higher than 100 in order to ensure we get elected as the active node. But there's a very important consideration here, and that is I can set the priority from anything to 0 to 255. But by default, let me ask you this. If router 1 goes down, what is the default decrement or the default value that the priority number will be decremented by? Exactly. It gets decremented by 10 by default. Now, In a much more advanced scenario, we would have interface tracking and we would be able to tweak things and use different values, right? And we can also indicate what that value is going to be, what we're going to decrement things by. But by default, it's 10. So if I say 105, that is going to be good enough. In fact, let's see what we see here. If I say standby 1 question mark. So take a look. We can, it actually shows a little priority tracking. We've got timer values that we can tweak. The priority is what we just set, and the preempt. This is very important. You need to have preempt on both sides of the configuration. And this is critical. If you do not configure preempt on both sides, and so let's say we don't do it here on router 1. So if I don't configure preempt on router 1, right? Here's router 1, and there's router 2, and they're both running into these switches here, our layer 2 switches like this, and this is where that layer 2 connectivity is coming from. So if 1 went away, 2 would take over. The priority value on router 1 is going to decrement by 10. It dumps it down below 100. So 2 takes over as the active because it has the preempt command. But what happens when 1 comes back online? So router 1 comes back online and thinks, okay, this is great, but without the preempt statement, it is not going to take back over. So both sides have to have the preempt statement. This is one of the more common mistakes that get made, is thinking that the preempt statement only needs to be on the backup. That is incorrect, right? That's incorrect. We need it on both sides. So let's see what we've got now. So we say do show run. And actually, I'm going to check to see if it gave me a point for that. Let's see if it's... I'll say no standby 1 preempt. Oh yeah, it dropped. So you can see it dropped the points away. So again, this kind of confirms what I'm telling you, is that we have to have this on both sides. Very important. So everything looks good, right? We're set to preempt and take back over if we go down and come back up. Standby 1, priority 105, right? So we're higher than the default of 100. Standby IP, so this is the virtual IP that is going to be seen, that we're going to configure on all of our hosts. We're just going to simply say 192.168.1.254. And this will be the node that's going to be advertising that MAC address. And we'll look on the switches to see what the MAC will be. I can tell you now that's going to be F001, right? Because 1 in decimal is 1 in hex. And so that's what we should see on the switch port when we take a look at the MAC address table. All right, so we're good here. Let's go ahead and sort things out on router 2. So we pull router 2 up, and let's give ourselves a little space here. Okay, so on router 2, we're going to start out with standby. The version is still there. Let me confirm that. Do show run. Version should still be there. It is standby version 2. So we're going to say standby IP 192.168.1.254. And you can see that we go into the init state for HSRP. And then we should transition into the standby state, and we'll give it some time here because it's, yes, speak to standby, right? And it said standby to active. But do you see the problem here, right? Should this be the active node? And the answer is no, it should not be. And the priority over on router 1 is greater. So if I were to say, whoops, sorry, let's pull this back. And did I leave? I think I left out. Did I say standby 1? So what was the problem, right? And this is great. Fortuitous failure. This is one of my most common mistakes, is forgetting to do what? Yeah, use the right HSRP group number. Because if you don't put a group number in, which I didn't, what does it default to? Defaults to 0. So let's pull that command back up. Right? And we're going to say no. Actually, let's say control. All right, we've got this runaway output here. So control, and here I'll just type it out. let's say no standby IP 192.168.1.254. And what did it not like about that? No standby IP 192.168. Let's try that again. No standby, I'll put 0, IP 192.168.1.254, and that should do it. So what we need in here is standby 1 IP 192.168.1.254, and it'll go from init, and then it'll go to speak, right? And we'll see that transition because it's going to be speaking to anybody else out there. This is another difference between HSRP v1 and v2. Remember, HSRP v1 is multicasting its packets out to 224.0.0.2, where HSRP v2 is multicasting them out to 192 to 224.0.0.102. Right? So it's the same first 3 octets, but the 4th octet, this is for v2. Okay. So it looks like we are here, and that is what I was anticipating prior, was that we would go from speak to standby and then hang in that state. So again, we're using the default priority. The command that we don't have on here is what? And it's probably the command that's going to take us to the 10 out of 10, and that is what? Yeah, the preempt command. Remember, that preempt command has to be on both sides of your HSRP configuration. So if I say do show standby brief, and actually we'll make this a little longer. There we go. Take a look. The active is 192.168.1.1. That's the physical IP address on the router 1 gig 01 interface. And this is also an important point. Remember, the IPs on the physical interfaces must be different with HSRP than the IPs on, or than the IP that you're using as your virtual IP. And remember, you're telling your hosts to point to that virtual IP because it will swing between the 2 routers, depending on which router is the active and which router is your standby. A very common mistake is that learners will configure the end nodes, these laptops here and the PCs, and they'll put the IP of the physical interface of one of the routers. And it's tricky because that works until that router goes away, right? So always use that virtual IP. That's why we're giving it the virtual IP address, because that's the address that we want it to use. And so we don't have the preempt command on there. Let's go ahead and say standby, make sure I get the right HSRP group number. Standby 1 preempt, my guess is that that is going to take me to the 10. It does not. So let's take a look at some of these in-hosts here to make sure. The DNS server, so we may have to do some configuration. So we are good from an HSRP perspective. Let me see, because what I'd like to demo, and actually before we do that, if I come to switch 3, and this is going to be tiny print, unfortunately, there we go, the switches are not cooperating. So we pull the switches up here. Let's give ourselves some more real estate. If I say show MAC address table, right? We should see, and absolutely we do, on gig 01, F0, and I know that's tiny, I apologize, I can't make it any larger than it is right there, but there it is, F001. And that is exactly what we were looking for, right? And that's the group number, the HSRP group number, are these last 3 hexadecimal characters. And so I can see that it's port gig 01 and that we're in VLAN 1, right? And so this MAC address will magically migrate over here to switch 4, right? If I pull switch 4 up, and I'm not sure Packet Tracer is going to be equipped to handle this in terms of showing what happens when we fail over. But yeah, you can see here, it shows the MAC, but out what port? And this is important. This is very, very important because you see the MAC address here and it says gig 02. Well, gig 02 is which interface? And let's prove this. This is a very important point here. Interface gigabit Ethernet 02, and I'm going to say shut. Yeah, it's that interface that runs between switch 3 and switch 4. So let's bring it up and say no shut. So it's back up there. Now, why is this important? It's important because take a look. Remember, we're providing first hop. The FHRP stands for First Hop Redundancy Protocol. So we're providing layer 3 redundancy with HSRP. And that's great. And remember, that layer 3 redundancy is what? Yeah, we have an address here, 192.168.1.254. And so it's the first layer 3 hop redundancy that we're providing. But remember, this is all, and so let's do this. Here's my layer 2, and there's my layer 3. So here's the layer 2, layer 3 boundary. And that everybody on this side's layer 2, everybody over here, my routers are layer 3. So in order for these end nodes to reach that IP address, which is configured as what on all of these nodes? Exactly, it's configured as our default, whoa, the pen gave up on me there. It's configured as our default gateway. And so when I send something, like if I'm on PC 0 and I say ping www.cisco.pka, not only is it going to have to do a DNS resolution, but ultimately it's going to give me the IP address. And it's going to show that that IP is not on the local network that I'm connected to. At which point the PC says, well, what's my default gateway? And it sees the address. But if that address is not in the ARP cache, the PC 0 node will send an ARP request out, and that ARP request says, hey, I'm trying to get to, and let's say for the sake of argument that Cisco PKA is 209.165.200.whatever, 33, right? But we know that that network is not the local network we're connected to. And so the ARP request goes out, and PC 0 says, hey, well, somebody configured me, either DHCP or the administrator, somebody configured me with a default gateway. And that default gateway layer 3 IP address is 192.168.1.254. I don't have the layer 2 information, so I don't know how to forward to get to the default gateway layer 3 address. So give me the layer 2 address. That way I know what's going on here, right? Because it's possible that switch 1 doesn't even have that information. And so what you see here is switch 4, right? This is switch 4, says that anybody coming to me to get to the default gateway, which is running on router 1 for HSRP group 1, I'm going to forward that traffic because this corresponds to 192.168.1.254 out gig 02 over here to switch 3 because it's out that interface right there that MAC address is being learned on switch 3. And so then in this layer 2 domain, everybody is going to ultimately see that to get to this layer 2 address, which corresponds to that layer 3 gateway, that HSRP virtual IP, that we ultimately need to come out this interface. So we're all going to be coming here to switch 3. And again, this is critical because you'll see this MAC address in different locations. We should see it here, and we should see it here for the layer 2 domain that we're talking about. Okay, so we see the MAC. We know we've got to pull this way. If router 1 went down, that MAC address is going to show up over here. And of course, these switches are going to need to relearn that information, but immediately he starts advertising, switch 4, that, hey, come to me to get to this. And it would no longer say go out gig 02. It's going to say come this direction. And let's force that to happen right now. This is a good time to do it because things are functioning, right? So we come over here to switch, well, actually, we don't even have to go to switch 3. Let's come to router 1 and let me go into global config interface gigabit Ethernet 01 and say shut. And now let's see if Packet Tracer is prepared to handle this. Now, there's HSRP packets that are going back and forth, right? That are keep alives. Let's come over here to router 2 and let's say, and take a look. Well, I love it. This is great. So we see I transition from standby to active. We get this speak to standby, but I'm active, right? So now I am the active node. Do show standby brief. Yep, who's the active node? I'm the active node because the other one has gone away. Router 1 is gone. So on switch 4, when I say do show MAC address table, let's see if this, whoops, MAC address table. Let's see if this changed for me. Aha! Take a look at that. I love it. I'm very happy that Packet Tracer is accommodating this request here and this kind of, this little demo. So take a look. Now what interface is switch 4 saying that it needs to get to that layer 2 address? That default gateway virtual IP. It's got to go to that layer 2 address out gigabit Ethernet 01 that we know goes directly to the router 2, because HSRP, right? It's that virtual IP swung, and the MAC address swung from being advertised here when this went down. It swings it over to router 2 because he's configured and he says, hey, router 1 is gone. So I am now going to be advertising that virtual IP and that virtual MAC address. It's over here. So let's look at switch 1 and switch 2. I'm going to keep pushing Packet Tracer here to accommodate us. And let's see. Switch 1 should say that it's going to be coming across this link here because that should be the quickest way to get there, but let's take a look. So on switch 1, we say show MAC address table, and it's going out fast Ethernet 01. Well, which port is that? Let's take a look. We're going to global config, interface fast Ethernet 01. We'll shut it down. Okay, so it wanted to go that way, but that's fine because switch 3 is now going which direction? It's got to be coming across that gig 02 link. So we'll get into, we'll say show MAC address table, and there it is. And now switch 3 knows, hey, my link here, that's not how I get to that layer 3, layer 2 information anymore. It's got to come this way. Same thing, switch 2. Let's see which direction he's going to go. And again, what is all of this based off of? What we're seeing right now. Why is 1 going to 3 and then to 4? And why is 2? And 2 doesn't see anything because it may have timed out, right? It may have dropped out of the MAC address table. Let me pull PC1 up here, and let's real quickly just pull up the web browser. And this may be where Packet Tracer gives up on me. So we'll pull the web browser up, and let's go to www.cisco.pka and see, do we get there? Is this going to work? Cisco Packet Tracer. Okay, so it worked. So, and this is great, right? Fortuitous that it wasn't in there because now, yes, I like this. So now when we run it, Packet Tracer is being very kind to us right now by continuing to cooperate. So I run that command. I say, hey, I'm going to go to www.cisco.pka. So what happens? PC1 has to ARP because he didn't have his default gateway layer 2 information in here. He says, hey, I know the layer 3 information because someone typed that into my configuration or I learned it via DHCP. But if you're out there, 192.168.1.254, hey, I need your layer 2 information, right? I need this layer 2 information to forward this traffic. And so then what do we get? We get this. Now switch 2 has that required information here, and it says it's going to go out fast Ethernet 02. Now it appears that that link is blocked, so let's see which link is fast Ethernet 02. And at this point, we will be able to see, let's do global config, interface fast Ethernet 02, shut. So it's that middle link, right? Does everybody see that? So fast Ethernet 02 is the middle link. And so when I'm looking at this, let's draw this out. So I'll say no shut. And again, very important, very, very important here. So what do we know? Let's go to green for our color because we've got a lot of red dots everywhere. So we know that switch 4, and again, we're going to say, hey, that link is down right now. So when that link is down, our layer 2 traffic is going to forward in this fashion. These two guys are going to come this direction and then over this link and out this direction to get to the default gateway. Switch 4, if there was a PC over here, this is kind of the obvious one. He's going to go straight here because that's his only connection out to that default gateway. And then these two guys are going to be switch 1. And did I leave those interfaces down? And I apologize if I did, because IP interface brief, they should not both be red, so maybe it's on switch 1. Did I leave those? I did, I apologize. Let's say no shut and bring that back up. And so then we come back over here. And so those two guys, right, PC 0 and laptop 0, they're going to go this way. So everything to the left of this line and this equation, it's all about the layer 2 traffic forwarding, right? And so what dictates how this traffic is going to be forwarded? And you can see these lights went green, so we are coming this way. These are both green, so we're coming this way. And these are both green, which is why he's going that way. So what's dictating why we're taking this route? Exactly, the spanning tree protocol. That is what drives the layer 2 traffic forwarding. And it's all based off of the position of the root bridge. And so again, I know we're troubleshooting HSRP here. I can almost guarantee that the only thing we're missing is the preempt command. So we want to dive deeper to make sure we understand, because we're getting ready to transition in chapters 4 and 5. When we transition to chapters 6 and 7, we're talking about EIGRP, right? And we're talking about layer 3 at that point. So, but we need to know, how do these two pieces plug together? How do I get from the layer 2 to the layer 3, and why is it important? And so let me tell you, and let's clear the screen here. Let me tell you what you typically see. So these are the two switches that are closest to these two gateways that we're going to be using. And these would be considered sort of our access layer, right? Do you see? It's kind of sideways here, but that's what it is. There's my access layer where I plug in my PCs, my laptops, my access points. There's my distribution layer, right? Where I maybe have my services, and we're all layer 2 at the distro layer, and that's okay. There's nothing wrong with that. And then this is my core, where I'm going to connect out to the internet, maybe over to a different campus somewhere, right? So access, distro, core. And here are your 3 layers in your hierarchy that we have in this setup. And so the layer 2, which is what we're most interested in, at the distro layer between distro and access, typically, right? Remember, never put your root bridge down at the access layer. It should always be here at your redundant distro layer. So 3 should be the root bridge, or could be the root bridge, and then I would have this guy as my secondary root bridge. And we're only dealing with VLAN 1 is what it appears, right? So let's go ahead, since the opportunity has presented itself here, let's go further down the rabbit hole and let's jump onto switch 3, because again, router 1, when it's operational, should be the active node. So let's pull switch 3 up and let's see who is show spanning tree. And again, you can see it's only VLAN 1, and boy, we got lucky right out of the gate. So who's the root bridge? Yeah, this bridge is root. So there is no question, and it's got the default setting. So I'm assuming that we're not talking, this activity wasn't a spanning tree activity, right? So we've got the default 32.768. So then it goes to MAC address. So the root bridge has been selected. Let's take a look at switch 4. And where is switch 4? But here's what I'm going to do, because this is what you would do in a, oh boy, not happy with that. Let's see. There we go. Here's what you would do in a real world scenario. I would say spanning tree VLAN 1, and we're going to make it for 4094. Oops, sorry, 4094, priority 0. I just gave it the lowest possible priority to guarantee its election as the root bridge. I'm not going to leave it to chance by the MAC address. And then switch 4, right, we want that to be the secondary. And so let's get switch 4 up. And so what I would say on switch 4 is spanning tree VLAN 1 to 4094, priority 4096. And now it is going to become the secondary root bridge. In case switch 3 explodes, it becomes the secondary root bridge. Now, I won't walk through all of the selections, the blocking and things like that, but we can clearly see which ports are blocking here. And it looks like even with that change, right, remember, it's all about the root bridge. And this is an important point as well. When I change the root bridge priority, right, and I change the root bridge election, it's not that I'm telling the PCs, right, that, oh yeah, you're going to send all your traffic this way. The root bridge, when it's elected, everybody else is making their determination, right? Because what can you see here? That's going to be, sorry, that was an R. That's going to be a root port. This is going to be a root port. This is going to be a root port. We know that these are all designated ports, right? Designated, designated, designated. So from this, it's very simple to see how the traffic is going to forward in this environment, in this topology, from a layer 2 perspective. And of course, that just goes out that way. And you want predictability. You want to know what's going to happen when something fails, right? And so then what you could easily do from this is maybe take those 3 links down and then see what happens, right? Which ports become, because this guy becomes the root bridge, so there's a designated port, designated port, designated port, right? So that would be the root port. This is going to be the root port. So if switch 3 goes away, we know that these guys are going to forward that way. And we know that these guys would forward at layer 2 this way. And again, it gives us predictability. You want predictability. You don't want to not know what's going to happen in the behavior. And this is true either at layer 2 or layer 3. You want to know what's going to happen when something fails, right? And so we saw what happened when that link went down. And we saw that the traffic continues to flow at layer 2, right? But it's just going to swing it over here because now that MAC address, and that was supposed to be an M there, this MAC address for the virtual HSRP group 1 is now resident here, right? It was learned here, and then he tells everybody else about that. All right. So again, very, very important. And let's go ahead now and bring this to conclusion, and we're going to go into privilege exec global config and do show run. And where am I missing? That's the preempt command is there. Trying to remember where we were missing the command. Let's say show run. The preempt command is there, and now I'm forgetting what command. Oh, I wanted to check. I'm sorry. We wanted to check and make sure that the traffic still flows. So we go to the desktop. We'll pull up the web browser here, and we'll say www.cisco.pka, and it works on 2. What about laptop 0? Desktop, web browser, www.cisco.pka. Everything looks good there. Laptop 1, desktop, and can we get to www.cisco.pka? And what about PC1? And this should work because it did earlier. Let's see, small page. All right, so we've got connectivity to everything. So I must have overlooked something. Let's bring this interface back up here on router 1. Interface gigabit 01, no shut. And we're also going to see the preempt command in action here. Because without this preempt command, we would not be swinging things back because there's already an active HSRP router. And so we should see do show run version 2. We're good. Yeah, do show standby. Let's see what it shows here. And there we go. Do show standby brief. So I am now, okay, so it shows standby as unknown. So let's give it a second here, and you can see we are the active node. Let's take a look at router 2. And speak to standby, show standby. And who is the standby router? It is the local, show standby brief. All right, so we know the active, we know the local. Let's make sure that both of these guys are in agreement. Okay, good. So the HSRP is working. It's something that I must have overlooked. Here, R2 uses the default. All users should be able to access it. We did verify it. Okay, so we disabled the Gig 0 interface. We didn't do it on R2. We did it on R1. And then they have you do it here, and we went deep dive as to why. And so on R2, let's make that happen. Let's go into global config interface gigabit Ethernet 01, and we say shut. So we'll shut that interface down. And it's the same thing, right? This is the secondary. So the active, nothing's going to change. So I say no shut, do show standby. So the standby router is unknown because we've got to give it some time here because the HSRP packets are now being multicast out to 224.0.0.102. Now you take a look at this. So he went from standby, he thinks he's active, says speak standby, standby active. But let's give it a second here. Do show standby brief. And so interestingly enough, yeah, see, he transitioned back to the speak state. Because initially he thought, hey, I'm active. There we go. Speak to standby. And now he sees who's active. But it looks like I overlooked something, and maybe it's an IP address or something like that. So let's see. I thought it was... Oh, the default. Well, now this is interesting here. So it looks like the default gateway, but it worked on laptop 0 and PC 0. So let's go back to our desktop config, the gateway 192. This is good. So you can obviously tell I have not done this activity yet, right? Because what is happening here? And this is, this is great. This is actually makes me feel good. So I spent that time talking about the common mistake of putting the default gateway in as one of the IPs, the physical IPs on one of the routers. And that is exactly what has happened here. So even when router 1 was down and then I brought it back up, this is working because I had a valid IP address in there, right? So we'll put the right IP in there. And again, it should always be the virtual IP. But it will work as long as that interface it's pointing to is functional. All right, so that is correct on that laptop. Let's check laptop 1. Aha. Again. So there we go. Now that should bring us to where we want to be, and you can see we ended up with that 10 out of 10. So fortuitous failure, right? I talked about how important it is on the in nodes to use the virtual IP that we're configuring with that standby one IP command. That is the default gateway, because that is the IP in the virtual MAC that will swing back and forth between the routers, that will ensure that we have connectivity out of our enterprise here to cluster 0. All right, well, that wraps up Packet Tracer Activity 4.3.4.4. I will see everybody Tuesday night.